Okay, we have everyone. We'll get started, okay? So last time we get started for function, okay? We get started for function. Today, let's review a little bit before we go ahead, okay? So last time we start with a function, okay? Today we are going to continue the function and discuss more advanced topic for function, and then we will move on to the next topic for loops, okay? We'll move on to the next topic for loops. So let's get started for first one. The purpose of the function you need to remember, okay? Why we need a function, okay? That originally we may have a print command, okay? And we say hello, okay? And then okay. Welcome to Python, okay? Okay, so we may have a print command for this 3 line. Okay, and we may want to print it for 4 times. So first thing is that make your code reusable. Okay, make your code reusable. So you may want to copy it for 4 times. This is okay for now, but if you continue to do that, that's actually stupid because you cannot copy for 300 times, okay? So 4 times may be okay, 10 times may be okay, but 30 times, I think that's a lot. That's a lot. So first thing is that function can be used to make the code reusable, okay? So you can use it later. Let me save it first, okay? So this one, I create a new directory called bf3b, okay? Second visit for brief Python chapter 3, okay? This one is called a function one. It's not using a function. It just, okay, run 4 times. So this one is function 1, okay? No function at all. Second one, we save as function 2, okay? And this is stupid because we repeat so many times. So in a way, we can actually define. So we do define def define hello. So we make it a hello function. And then we push all the code 1 tab back, okay? 1 tab back to the right. 1 tab is 4 spaces, okay? If you count it, it's 4 spaces. So make it a function code. So this is a definition of the hello function. And then we can call the hello function for 4 times. So the first purpose of the function is to make it reusable. Okay, and this one we save as function 2, okay? So basically, the hello, def hello is to define the hello function, but it won't be wrong, okay? And the lower part, we run it for 4 times to call the hello function. So call it for 4 times. So this actually work, okay? This is function 2, okay? This is function 2. So let's save as a function 3, okay? We save a function 3. So this one, function 3, we can further parameterize it. Okay, so first purpose is make it reuse. Second is parameterize it. So you can have the call, okay? So that's create a variable called language. So here we pass language as long as it's a string is fine, okay? So here Python and then we pass language, make it a parameter, okay? Make it a parameter. So you pass the language in and that can replace the language len, okay? So here we actually can hello Python, okay? Hello Java, okay? Hello Rust. Rust is a language, okay? Hello C++, okay? So this actually parameterize a function, okay? So that's the second purpose of using a function is to parameterize it, okay? And run, okay? So this time, the wrong result, I'm sorry, let me bring up the idle window. So you do say, hello, welcome to Python, enjoy Python, Python is not hard. Hello, welcome to Java, enjoy Java, Java is not hard, okay? So this one actually make the part of the call parameterized. So you can reuse the call and then changing the parameters, okay? Any questions so far?
No.
Now we save as function 4, okay? Titus, are you okay so far?
Yeah.
So we save for function 4, okay? Function 4, we not only doing parameterize, we actually provide return, okay? Provide return value means right here, we finish everything, but we will return the length of the language word, okay? So here, let's call it LL equals this, okay? So here we do print the language name length is plus. Here you use plus, you must use str to convert the integer back to the string, okay? Now let's actually copy this one for 4 times. Let's copy this part for 4 times. So third one is to provide the return value. First one, make it reusable. Second one, actually parameterize it. Third one, okay, actually provide the return value. These are the 3 purposes of a function, okay? You must remember this, okay? Okay, this is function 4. Okay. For Titus, what are the 3 purposes of the function? Hello? Hear me? Hi, Titus, do you hear me?
Oh, hello? Can you
Yes?
hear me?
Yeah?
Oh, okay. Sorry, my microphone was
What are the
uh
three purposes of the function?
to be reused, to be able to use parameters and to get information.
Can you repeat again?
To be reused, to be able to use parameters and to get information.
Okay, must use the word I talk about, okay? Servant is to return the return value, okay? To provide the
Okay.
return value. You will make it a function because you want to return something, okay? Good job. I just actually will make sure that you are actually paying attention to the class, okay? Some students sometimes just doze off. Okay, these are the three purposes of the function, okay? The three purposes of the function. And then let's continue, okay? Let's continue. So these are the function's purpose. So next one, built-in functions. Okay, built-in function. So what is built-in function? Built-in function is a function that provided by the Python itself. Without defining function, you already know it. That's called uh, the the function. Okay, that's called a built-in function. Okay, so let's look at the one built-in function called bigger. Okay, the py. So we have three numbers. Okay, we have three numbers. So a equals integer input. Okay, this is a, and we want to run it for 3 times to get ABC. Okay. So get an ABC, then we would like to find out who is larger. So let's do M equals larger of the A, B, C. Okay, now larger is undefined yet. Okay, we don't know what is larger. Okay, and then we say M plus. Okay, this M is a number, so we need to convert it to string. Okay. Okay, now we want to define a function that actually calculate for the larger one, that for x, y, z. Okay, if you have nothing, you can just return 0. Okay, and this one we call it a stop function. Okay, so stop function is a wrong function. It's a fake function that just return 0. Okay. It's just a function that make the compiler happy. Okay, it's called stop function. So right here, let's run it. Okay, that's this one. Let's call it larger. Okay, so we can enter 1, 2, 3. So the larger one is 0, is wrong, but that's how it works. Okay, that actually uh, is the 0 that we return is a fake function. It doesn't calculate the right value. Okay. Okay, so that actually doesn't return the right value, but it's okay. This is a step. We just make the compiler happy. It doesn't calculate the larger one. So here let's save as here let's name it larger one. Okay. Now let's see. Let me ask Sarah. 3 number, how to find the maximum one?
Like without the function or?
Write it in the larger function. Let's assume that you are writing the define function. You are writing the
You
larger
can
function for me. How should I type?
use if statements.
Yes, go ahead.
Okay, so if x is greater than y,
Then,
then you can like save another one. Or yeah, x greater than z, then return x.
then, what should I do
If
here?
y is greater than z. Return y.
Okay, is this okay?
Um, yeah, I think so.
Okay. Okay, so this one is one way to write it, but the safer way is that here you put the equal sign as well, okay? This one it actually is greater than y, okay? So if it's equal, then x will be compared, y will not be compared, okay? Okay, anyway, writing with equal will be safer, okay? Okay, this one is a bigger one. Okay, this is one way to write it, but there are many ways to write it, okay? So, okay, before we actually get out of here, Titus, how can I modify this program? I don't want it to be this long. Can I modify it?
I'm not sure.
Try.
Uh, let me see here. Maybe, maybe, I don't know.
How about Harrison? Can you modify this program to make it shorter?
Is it just to like make ABC into like XYZ? So like
ABC and
you don't
SYG is the same. They do the same calculation, though no change.
yeah, so like you switch out ABC into XYZ to like use a line of code.
No, we need a function. We want to use the function. Okay. What you say doesn't actually make the code shorter. Okay. So one way you can make the code shorter is that this else is not needed. Why else is not needed? Harrison, can you answer why else is not needed?
I don't know.
You don't know? Try, think about it.
Is it because it's like on the second line of code?
Why? Why on the second line of the code you don't need a else?
I don't.
Is that okay? Because x greater than z, x already been returned. It terminate, the program terminate. So anything left over here is return z. Is that okay?
Yeah.
So let's call this one larger 2. So the same program you can write in different way, okay? So that is not needed. Sarah, can I further shorten this one?
Like you mean like after like removing the else?
Yeah. Can I still make this one shorter?
You can take out the return z in the first one, I think. Yeah.
Take out this one. What else should I do?
The return z can be moved to the
Yes, this is a common factor, common term. Okay? When it become a common term, both will do it, and then the return already gone. This actually will guarantee this z is the largest one. So you put in the else or not in the else, actually it doesn't matter. So this one still work. Okay, so this is larger 3. It will still work. Okay, good job. At least you notice a common term you can factor out. Okay, that's a good, very good. Now let's actually save us bigger 4. Let's do everything over again. I put a pass. I put a pass means that I still don't know how to write it yet. So this pass will do nothing. Okay, pass will do nothing. So now let me ask Titus. Can you think about a different way to find the larger one among A, X, Y, Z?
Maybe using the ands, like the if x is greater than y, then x is greater than z.
So you say if x greater equals y and x greater equals z, then x is the largest one. So we return x. Now, what else?
If y is greater than z, return y. And then underneath that, return z.
Yeah, this is one way you can write it. Okay, good job. This one actually is good so far. But if we have 11 numbers, this one won't work. You have to write 11 if statement. Okay, and then that's a lot of work, but it's okay for now. Okay. Okay, so Harrison, what's your question?
Can you use like the max function?
Hi, Harrison. What's your question?
Well, can you like use the
I
max
don't hear
function
you.
instead? Hello?
Hello, say again. What's your question?
Can you use the max function instead?
Yeah. You can use the max function instead, yes.
Oh, okay.
So this one is, we are discussion of how many kind of things you can do, okay? So this one is, let me see, let me check, okay? We just talk about every possible way. When you can think of anyway, here we don't say it's good or bad, okay? We just want to make sure that you really, this one, okay, this one 4. Okay, now let's look at the number 5. Okay, Harrison, as you wish, can you write something to use the max function?
So max and then put in like the XYZ. Could that work? No, max. Yeah. And then like,
And this one is using the built-in function. Okay, that's the built-in function we talk about is from math library, but this is cheating. Can you use a max function with 2 entry, not 3 entry to write the function?
so what was the question?
Can you use only max function with 2 variable, 2 parameter, not using 3? 3 is cheating. You basically just call the system built-in function.
So like, do I compare between like X and Y?
Mm-hmm. Okay, but then between X and Y and then?
And then like, you like compare like the bigger one with the Z.
Okay, I just want to make sure you understand it, okay? So this is okay. This actually is okay. I'm sorry, I messed up. This one should be larger 5, okay? I killed the larger 4. Sorry for it. Let me open the larger 4 and rewrite it, okay? Because later I want you to be able to see different version. I kind of save it incidentally. So this one, let me rewrite it, okay? So this one, larger 4 is if x greater than y and x greater equal to z, return x if y greater than equal to z, return z, y, okay. And then return z, okay. So let me change back to larger 4. Sorry, this actually happened because I incidentally saved the wrong file. Okay, this larger file, that makes sense. But Harrison, let me ask you a question. If I have 6 number A, B, C, D, E, F, how can I compare?
Like put more like
How
max.
can I put more?
By like adding more max and then like
Yeah,
the
how
number
can I
at the end.
compare? How can I compare one by one? Just using the 2 parameter one to compare.
Like you having like a long list of like return max, like with two like numbers, like two like letters in it.
So tell me who can compare with who first.
You can compare A with B.
Yes, and then you compare A with B, and then
the other one C and D.
Mm-hmm.
And then E and F.
Mm-hmm.
And then like to compare like if B is like greater than A, then compare like B with like the greater one between C and D. Yep. And then like compare like that. Like if like yeah.
Okay. So this one is a single elimination game. You go to play tennis, right? You go to play the so-called table tennis, ping pong, okay? And then they do single elimination. So there's a round of 16, round of 8, round of 4, round of 2, semi-final, and then final, okay? So that is using the single elimination game. And you use the built-in function for it, that's fine, okay? And maximum function can put multiple variable there, that's true, but we don't want you to think that way. Here we are teaching you how to think, not just coding, okay? We want to check how you think. So I don't want you to just rely on the built-in function. Okay? Now one more problem. So today we have extra student from Taiwan, okay? So let me ask them some question. So Roying, do you know any other way of comparing XYZ other than what have been covered so far? Can you think of other way? Hello, hear me?
Yeah.
Can you think of any other way? That's the part I want to teach, okay? I don't just teach you one way to solve the problem. There are many, many ways. And that's computer science, okay? That's computer science. We want you to figure out as many ways as possible. And then later knowing how to pick the best one, okay? The best way to calculate it, that's called the best solution. So can you think of any other way to do it? You have XYZ, you can do single elimination. You can compare X to Y and then X to Z, and then or is X to Y and then Y to Z. Okay, that's actually you can do comparison like that. Any other way? No, you don't think of any other way. It's okay if you cannot. That's okay because so many way already.
No.
How about Roshan? Do you know how to do another way? No. How about anyone?
No.
Anyone who can think of another way?
You could use like a loop to compare.
Can you say it louder?
You could use a loop to compare the three variables.
But we don't have the index right here. We only have 3 numbers. Yes, when you have 10, 11 number, you can do loop. But before we jump to loop, I only have 3 numbers.
Okay.
X, Y, Z. I'm not in the array or list. You want to make a loop, you have to make them in the list. Okay?
Okay.
How about Sarah? Do you have another way?
No.
Actually, we cover in APCSA, okay? So make X as the champion. If Y greater than M, then M equals Y. if a G greater than M, then M equals G. And then at the end, we return M. Okay, this actually, previous one, we do have single elimination game. So A compared with B, then compare with C. Okay, this is single elimination. This one is called challenger mode. Okay, challenger mode. What is the challenger mode? You make A as the winner, challenged by B, winner maintained to be M, challenged by C, and then we pick the winner. So every time the remaining champion keep being challenged by a new person. Okay, so this is challengers model. So we give you so many modes, so many kind of the way to do it. Okay, just because we want to show you there are multiple ways to write a same program. They end up with the same result, but you need to pick the best one. Okay, and then let's look at the here. Let's look at the largest 7. So largest 7 here we do have ABC. Okay, right here I can put it as star ARGS. Then here I say ARGS 0. One, one, okay. This is the technique called grouping of the parameters. What does that mean? It means that you group the A, B, C together to make it a list. So it becomes argument S, that's a list. So you assign the first element to M, then if if actually is greater than the second one, because second one is greater, then you make the larger one as the second one, and then the third one. Okay. So this one you run. You still type in 3, 4, 5, you still get the same, okay? Now let's make it a number 8, bigger 8. Okay, bigger 8, this one, let's actually put in another one called D, okay? So put a D over here. This one the same, but right here we don't do it anymore like this, okay? So we do for actually each X in arguments if X greater than M, M equals X. At the end, we return M. So this is what Titas say. You can use a for loop to solve it. And it's based on the bigger 6 algorithm. So that's why I stop him. I don't want to explain the 3 element for loop. Titas, is that okay?
Yeah.
Does that make sense?
Yes.
Because right here I save it for 4 elements. Okay, 4 elements still work. You try 6 elements, 7 elements, as long as you put it over here, it will work, okay? It will become a for loop, and you use a for loop every time you use a number to challenge the winner. If you are greater, then you pick that, okay? This is a for loop version of finding the maximum. So right here, we are already bigger A. We have so many versions, okay? Every single one work. And the bigger 3, we use the built-in function. Built-in function is using the function inside the Python language that already defined for you, okay? So that's called built-in function. There are many kind of built-in function. Maximum or minimum is just one of the built-in function, okay? You can also do maximum on a string. Then we'll pick the word, the letter, that with the largest ASCII code will be returned. So in this case, you'll return W. Is that okay? So max function, yes, max function can compare multiple data or multiple numbers. Yes, that's true, okay? But that's built-in function. At this moment, I don't want you to just call it. Just call it means you are not thinking of what else other way can do, okay? But when you do real-life programming, this actually is faster. You don't design the max for yourself, okay? Hi, Harrison, is that okay so far?
Yeah.
When you do daily competition, you want to do this, nobody say no, okay? It's okay. But here we are teaching, so we want you to figure out which one is the best way to do it, okay? So this is string conversion, we finished it already. Built-in function, we finished. Custom function, we already say define many custom functions, okay? So these are done. And there are many built-in functions, okay? Parameter, we talk about parameter, okay? So now next one, we are going to call it function. Okay, let's go back to function. Function series. Function series, we finish up to function 4, okay? And we also told you how to do grouping on a parameter, okay? So that's important. So try another one. This one, let's actually do new file, okay? Let's call it, I'm sorry. Let's save us. This one called hint. Okay, hint. What is a hint? Hint is also related to function. So let's do hint.py. Okay, so we define a function. Let's call it square. So you have a x input, and you do return x star 2. That's actually x square. Okay, you can have define a cube of function for x. You do return x star 3, okay? And you can do print square of 2, print cube of 3. Okay, so that's a regular function, okay? And you run square of 2 and cube of 3. That's fine. But now, does it save us hint number 1? Hint number 1 right here, I say, I don't know what x should be. So I say integer, provide a hint to know about what it is. And then return value is also an integer. Okay, so these are hints. It gives the hint of what type of the data it is for the parameter and also for the return value. But these two things has no effect on the program. So hint are of no use in the program. Just to provide hint. That means you put in a floating point number, it will still work. You put in a string that will still work, okay? As long as you can do the power calculation, it will still work. So basically, this hint or no hint, Python will do the same thing. Is that okay so far?
Yeah.
Okay, that's the hint. Next one. Next one is called default value. Okay, we want to have a default value. What is default value? Default value is, okay. So we define a function, it's called add. So we do have x, y, z. Okay. Then we will do c equals add 3, 4, 5. Okay. And then print c. Okay, so right here we just need to return x plus y plus z. Okay. This is the regular function. So the run module, you print out 12. That's correct. Okay, that's correct. But now there's a problem here. Sometime, if I just provide 3 and 4, what'll happen? But your z is missing. Your z is missing, then your program won't work. So you're missing the z. So in that case, can I put the equal 0 over here? That's a default value. So that one means when z has no value, it will use default 0. Is that okay so far? So with that, we can also make a default value for x, y. Okay. So we do c equals add 3, print c. Okay. C equals add, print c. Okay. So one number will be considered to be x. 2 number it will be x and y. 3 number will be x, y, z. And if you missing some value, the default value will be assigned. Does that make sense? Any questions so far?
No.
Okay. C equals this one is called out of order assignment. When you assign a value, but that's not according to its order. Okay. And you don't have x, so x will get the default value of 0. That should still work. Okay, that should still work. So we talk about hint, we talk about default value, we talk about grouping of parameters. We learn enough, okay? We learn enough right here. So the parameter, the XYZ is called parameter. ABC is called arguments, okay? And you can also call the ABC as actual argument, actual parameter. So you have a function x return x squared, and you do call function of 2, this value is called actual parameter. Sometimes it's also called argument. This x is called formal parameter. Okay? And if only parameter, usually is talk about this one. Okay? Any question? Any questions so far?
No.
Okay, no question. So the parameter, we are done, okay? Return value, we talk about it already. Okay, return value, we talk about it already. Put it together, okay, fine. Okay, let's have a 5-minute break, come back on A55. We'll start a new topic called loops, okay? So break right now, okay? Okay, I'm back. Any questions so far?
No.
Okay. Usually when we are 1 hour, okay, I'll give about 50 minutes to 1 hour. I'll give you a break. Okay. If I forget it, you can ask for it, but sometimes we go over it. So if you are tired for about an hour, because this is online course, it's very easy to get tired or doze off. Okay. So around 50 minutes or 1 hour, you can request for a break. Okay. I usually would say okay. Unless that we haven't finished some topic, we will get a little bit longer and then break. Okay. But we'll give you a break during the middle of the class. Sarah, are you okay so far?
Yeah.
How about Titus? Are you okay so far? Titus, you say something, but I didn't hear.
Oh, yeah, I'm okay.
Yeah. I see your microphone move, but no sound. Sometimes you mute it or sometimes.
Hello?
Yeah, I hear you. You have to
Oh,
turn it louder, okay? Most of the
yeah.
time, I don't hear it. Next one, we are going to teach you loop, okay? We don't teach you every loop. We just teach you some basic type of loop. Okay, so first one is the so-called repetition loop, okay? This one, let's bring up the function 4 that we have. So function 4, we put in different language, right? No, we don't want function 4. Let's open the function 2, okay? So function 2 here, we actually print this, and then we do 4 times. So we would like to rewrite this hello call. So we want to do it 4 times. So we do counter equal 0, while counter less than 4. Do what? Do hello. So tap it and we close it. So every time you finish it, you say counter plus equals 1, increase by 1. Okay. Okay, this is a while loop. So flow chart, you'll be like this. You set a counter to be equal 0. You go in here to check if counter less than 4. If yes, less than 4, you run hello. Then your counter increase by 1 and go back to check it. So when counter equals 0, you print the hello part once. And then counter become 1. And then you print once, become 2. You print once, become 3, print 1. Become 4, it doesn't print. So basically 0, 1, 2, 3, and 4. 4, you don't run it. So 0, 1, 2, 3, you print it, print the hello part, each one of them once. So this we call it repetition loop. Is that okay so far? Is that okay so far?
Yes.
Yeah.
So it actually will count for 4 times. So we do not write the hello, 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 hello 4 times. Okay. We use a counter to count how many times we will do. Harrison, are you okay with this one so far?
Yes.
Okay. Now, Harrison, let me give you a question. So here, if I have a 10, what will happen?
Oh, then it won't run hello.
And what will happen?
It'll give you an error.
No, it won't give you an error.
Like it just won't print anything.
It will jump to here. Is that okay? It just never go into the loop.
Okay.
Oh, I make a mistake. This one should be function 5 again. So let me save us. Let's call it function 5. Okay, I saved to the function 2. That's wrong. Okay. So this one won't go into there. So let's open the function 2. Okay, I need to modify the function 2 again. I saved something wrong to there. Oh, it's okay. Function 2 not modified. That's fine. So function 5, you won't get into there. Okay. So usually you start with 0. Okay. If 10, you jump to here. So sometimes you get into the loop, sometimes you don't get into the loop. Okay. So let's look at function 6. So function 6, if I forget to put this line, then what will happen? You'll never end. Okay. You'll never end. It will never end. So this one we call it function 6. Function 6, this one never end. We call it infinite loop. Never get out. So this is a bad loop design. So if you do not design the loop well, you may end up designing the endless loop. Okay, so this is bad. So let's actually open the function 5 one more time. So function 5 is a counter loop. Okay, it's using a counter loop. Okay, let's save this one for function 7. So sometime, I don't know how many times I would do. Okay. So basically I'll do this, actually, integer input, enter a number. Okay. And then right here, I change it to counter not equal 999. Okay. So this one is function 7. So I do hello, but I don't update the counter. I actually read it in from keyboard. Okay. Now, so this one is save and that's wrong. So how many times this one it would wrong? I don't know. I enter 3. I enter 4. I enter 5. I enter 10. No matter what number I enter, it will not stop except for 999. So 999, the program will stop. Okay, this is called sentinel loop. Okay, wait for the sentinel. Sentinel is a guard, gatekeeper. Okay, so this kind of loop, you can do it as many times as you wish, except for you enter 999, the loop will stop. Any questions so far? Any questions so far?
No.
No.
Okay. So when will this program stop run? When? This one for Titus. When will this program stop run? Under what condition?
Under the condition that it doesn't equal 999.
No, the opposite.
Oh.
It actually equal, only equal 999, it will come to here.
Yeah.
So basically, if here you do have an A condition, if this counter not equal 999 is A condition, you get out of the loop, it must be not A condition. Is that okay?
Yeah.
The while counter not equals 999, you will continue. Okay, as long as it's not 999, you will continue. But if you get out of the loop, that one thing we can guarantee is that the following call would have counter equal 999. That's the post loop condition. That will always happen. Okay, that it can guarantee that. Okay, that can guarantee. This is something you need to remember. Sometime later we'll use this feature to design a loop. Okay, sometime later we'll use this to design a loop. So far we introduced something called while loop. Okay, while some condition you do something, and we introduce the counter loop, the infinite loop, the sentinel loop, okay, and also the post condition of the sentinel loop. There are some other loop, okay, more complicated loop, but at the pre-Python level, we don't touch it yet, okay, we don't touch it yet. So today we, this while loop, we are up to here, okay. Next one, we are going to create another one called for loop. But in Python, there's no regular for loop. It only has a for each loop, okay? It only has a for each loop. So that's actually copy, open the function file one more time, okay? This one is the function file. We are going to copy. We're going to pass on the this is from function file. We are going to put on a for loop. So let's put it over here. This one is called for each loop. So let's get started is for each one, okay, function. So we'll rewrite this one here. So we'll do it for 4 times. Okay. So right here, we are going to do for each x in 0, 1, 2, 3. We will do hello once. Okay. So this means that every time we pick a number from here, so x equals 0, we run hello. X equals 1, we also run hello. X equals 2, we also run hello. X equals 3, we all run hello. So we say this one is for each loop is actually for each value in the list. We run the for loop once. Okay, so this one, let's actually run it. So it's the same. Okay, it's just print the same with the hello function 2 or function 5. Okay, it said that this one we use a for each loop. Any question about it so far? So next one is what can we put over here? Okay, what can we put over here? So let's look at for each 2. Okay, this one is now let's see. We can for each character in A, B, C, D, E. We print character. Okay, this is for each character in a string. Okay, we can have for each tuple in the tuple of 1, 2, 3. Okay, and you print your tuple. We can have for each X in the list. Okay. Okay. So apparently this after the in, you can put any data collection. It can be a string, can be a tuple, or can be a list. Okay. Any one of it is fine. So far, okay. So far, okay.
Yeah.
And this type of data collection, we call it iterable. Okay, something that you can iterate through one by one, going through the, we call it iterable data structure, that including string, including a tuple, or including a list. Okay, any one of it is okay. Okay, but sometimes we use different things. We do for each I in range 0 to 10, print I. Okay, Titus, what will happen to here?
It will create a bunch of numbers.
What
from,
are the bunch of numbers?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay. So this range function, when we do the string slicing, we talk about here, you do have 3 numbers. It's a starting, ending, and jump value. So when you only have 2 values, that's starting and end. When you only have 1 number, that would be the ending one. And S will be assuming 0. Here, jump assuming to be 1. Okay? So far, okay?
Yeah.
How about Harrison? Are you okay?
Yeah.
Okay. So this one is for each loop using range function. Okay, range function we talk about, you create a tuple of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, not including 10, up to 10, but not including 10. Okay. So that's for each I say it's index. Okay. T for tuple, X for element, and then CH for the character, and then I for the tuple. So sometimes I do for each I. Right here, I can also do, let's assume I have a string equals A, B, C, D, E, F, G. Okay. Then I can do this. I can do for each I in range length of S. Print S, the index value. Okay, so this one, Harrison, what happened here?
It will print 7 S's like A B C D E F G, like 7 A B C.
Each element will be printed, but this time you are not using the element to print. You actually get the index and then use the index to find the string elements. Is that okay?
Okay.
It's a slightly different from the first one. First one, you get the element and you print the element by itself. This one, you don't get the element. You get the index and then you use index to find the element to print. Okay. So this one is range length of the S, but length of the S not included. It's starting from 0 to length of S minus 1. Okay. Okay, so these are different type of the for each loop. We talk about it enough already. Okay, so that's fine. Let's move on. Okay. So next one, let's look at this input loop. Okay. So let's look at loop. Let's look at the a new file. Let's actually call it input loop. Okay. Okay, so right here, let's do input 1. Okay, so this input loop, you want to get some value. So you say, let's do S equals input or enter a value. Let's assume it's a number. So you get a S right now is still a string. Okay, I call it S because it actually equals a string. So while S not equals exit, okay, then I do this. Okay, okay, and I do number equals int of S. Okay, I convert it to a number now. So right here, I have something called total equals 0. So total will plus equal number. Okay. And then I say S equals input. Enter a number again. Okay. And then finally, when I get out, I print total amount. Okay. Comma total. Okay. So this one is called input number 1. Run. This, I think I talked about it before. This is in the REPL format. Okay. Read in, evaluate, print, and loop back. Okay. So I do 2, 4, 7, and then I want to finish. I type in EXIT. Get out. Okay. Get out. So every time you read in a string, if the string is not exit, you continue. Okay. And then you add the number to the total, add the number to the total until the number you enter is exit. Okay. So this type of loop, we call it REPL loop. Read, evaluate, print, and then loop back. Okay, print is doing something, so you sum up to total, that's fine. Okay, loopback is doing again. Okay, so far okay. This is called REPL loop. REPL word is a lot often used. Okay, so there's a website called replay.it. Okay, Python. So you can find an online compiler interpreter called replay it repl.it. Okay, and there are several things that are over there. So you can sign up for a Python code. Okay, whatever they are, you can do online. It's free for students. Okay, is that okay so far?
Yeah.
Okay, so this is REPL loop. I don't intend to go even harder loop. Okay, so this is input loop. That's up to here. Okay, I don't follow the loop in the textbook. It's too bad. That's not good loop. Break levels. Okay, break levels. A loop may have different break levels. Okay, may have different break levels. So let's create a new file. Okay, this one called break1.py. Okay, so let's define a function. Okay, let's call it loop with an integer n. Okay, and then let's have another number called m. Okay, so you do this for I in range of n. Okay, you do n times of these. Okay, and then you do this. You print I. Okay, and you would do this if n equals actually m I equals m, then you do break. So let's call this one loop B. Okay, loop B. So this one print after break. Okay, right here you print after loop, after for loop. Okay, this one right here would run loop B 10 and 3. Here you print after loop B. Okay, so this is break level number 1. You break the loop. So 0 is say after break. You go and print after break. Okay, 1 will print, 2 will print, 3 you won't print because you already finished your level. So 3 you jump out, break out the loop. Okay, so here I actually call it loop number 1. Okay, instead of calling break, I call it loop. Sorry. Is that okay so far? This one is to break the loop. So when you run and then I equals 3, the whole loop will be break. But after loop, it will still be run because it's still in the function. So that's why you do see 0 after break, 1 after break, 2 after break, 3 no after break, but it will have the after loop and then after loop B. Okay. This one's called loop number 1 is the first break level, is break the loop. Second one, let's look at loop 2. So this one, let's call it loop 2. It's a second break level. Here we will put a continue. So continue will skip the rest of the iteration. Okay. So basically 3 will not have the after continue. Okay. Other than, and then you will still go for 4, 5, 6, 7, 8. Okay. So actually continue is to break the rest of the iteration. Okay, one iteration is from for I equals 0, that's one iteration. 2 equal 1 iteration. Okay, so this one, it will break when 3 no after continue, 4, 5 continue. Okay, any questions so far? Can you see the difference between using break and using continue? Any questions so far?
No.
How about Sarah? Are you okay so far?
Yeah.
This is the same as the Java, okay, or C, okay? These are the same. So let's look at the third one. Let's call it loop number 3. So this loop number 3. Let's call it break the program. This one you will need to import sys. And you will call system.exit 1. You break the program, okay? So that's a save. After that, no more for after for loop. After for loop B, it actually just break everything. The program just stop. No more. Quick stop the program. So this one usually when you have something wrong in the program, you will shut down the whole program right away. It's using this system.exit. So you won't run your program anymore. Is that okay so far? Any questions so far? Any questions so far?
No.
So next one, definite loop. Definite loop, we talked about it already. Counter loop or some loop that will finish, okay? Indefinite loop is a loop that will never finish. So this we know already, okay? You can put a string there, okay? That's fine. We actually don't explain this. We already talked about it. Loop applications, okay? So loop application, they are control loop, index loop, continue loop, sentinel loop, statistic loop, input validation loop, 2D index space loop, histogram loop. There's so many different kind of loop. Okay, let's see. There are tons of different loops. Let's finish the slice first, okay? I won't go into every single loop. This may be too much right now, okay? Too much right now. So if you want to learn every single kind of the loop, that would be an AP Comp Sci A course, okay? This one too hard right now. So let's see, we just cover the loop covered by the slices. So here print it before, and you go through every single number. Okay, this is basic loop. And then find the largest value, okay? Find the largest value, yes, you need to learn it. So this one, okay. So let's talk about is finding the maximum loop one, okay? Okay, this one, let's do create a new program. This new program, let's save as this one is called stats. Okay, let's call stat.py, statistics. So let's assume we have a value A is a list. Okay, so 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have value 1 to 10. So we want to find the maximum value among these. So define largest of the A list. Okay, so we get a list. We want to find the largest one. So we say M equals A list 0 for each x in A list. If x greater than m equals x, then return m. Okay, this one in the maximum we talk about it already. Okay, and define smallest, also A list, m equals. Okay, I'm sorry, this is equal sign. A list of 0 for x in A list if x less than m equals x. So you can see that the maximum loop and minimum loop, there's only one comparator difference. Is that okay so far? Only one relational relationship operator here. Only this and this difference. It's okay? So far, okay?
Yeah.
So this is find the largest value and the smallest value. This you need to remember them, okay? Because it's so common to use this. Okay, let's run it. Okay, make sure there's no bug. Okay, the largest one's 10, smallest one's 1. Okay, now next one, getting the sum. Okay, so you create s equal 0. And then for each X in A list, S plus equal X, okay? At the end, you return S. That's the sum, okay? Now next one, average. Okay, you call the total, so T equals total of the A list. And then you return T divided by length of A list. Is that okay so far? These are total and average.
Yeah.
Of course, in Python, there are programs that you can calculate this, built-in function that can calculate this, okay? But at this moment, we are not teaching that, okay? We are not teaching how to use the built-in function, okay? Here, we want to train you for the basic programming, okay? Okay, so these are 4 basic statistics of a list. Okay, total 55, 10 number, average is 5.5. Okay, this one is correct. Any questions so far? Any questions so far?
No.
So here we finish the summing. Okay, here another one. Okay, counting loop. Okay, counting loop. Counting. So define even count. So how many even number? Okay, this is called even count. So counter equals 0 for each X in A list. If actually A list actually X 10 modular by 2 equals 0. That means that it divide by 2, remainder is 0. Then counter increase by 1. At the end, we return counter. Okay? So that's number of even numbers. Okay? That's a counter loop to count how many even number they are. So even is not defined. Oh, okay. It's a even count. Okay? Okay, so 5 even numbers in there. This is fine. Average, we finish. Counter, we finish. Filter, you can delete some number that's not you don't want. Okay. So filter, you just use the if loop to delete the value from the loop, or you can not printing it or not adding to a new loop. Okay, that's fine. Okay, we are done with chapter 3. It's 9:40 now, so we basically done with the chapter 3 today. And next one, we are going to move on to the last chapter for brief Python. Okay, next week we probably will finish that, and then we will go back to teach you the Python programming essential and data science part. Okay, more advanced part coming soon. Okay, 1 more week. Any questions so far?
No.
No. No. One more thing is that in the Monday and the Thursday, we do have coding practice now. I need to make sure that you have finished your what's that? Your solo learn. Okay. So Harrison, can you show how far you are in the solo learn? Okay.
I finished all of it.
You finished everything. Can you show
Yeah.
your certificate?
Do I upload it to Facebook or do I share screen right now?
Just share screen. I just need to see it. Making sure you finish.
Okay, let me get it up.
Is that very hard or okay for you?
It's okay.
Did you get help from your dad or no?
No.
No? Okay, make sure, okay? I want you to really be good, okay?
Can you see it?
Yeah.
Okay.
Good job, okay? So see you on Thursday for the coding practice, okay?
Okay, what time is it, like 8?
8 p.m. Pacific time. So it should be, if you are in Taiwan, that will be Friday, 11 a.m.
Okay, thank you.
Okay? How about Titus? Can I see where you are right now for the solo learn?
Okay, let me share my screen.
I need you to finish it, okay? But here I just want to make sure that where you are.
I got my certificate.
Yeah, show me.
Okay.
Show me the solo learn as well. I need to see you, okay? So the solo learn also easy for you?
Yeah, it was pretty easy.
Okay. I think you have some programming background, so I don't worry, but I still need to check if you do finish it, okay?
Okay. Okay. Do you see my screen? I have.
Yes. Okay, good enough. Okay, good enough. Thank you.
Okay.
How about Sarah?
I did not finish it.
Okay, but you need to catch up, okay? I know you can do it because you finished the CSA, but you need to finish it, okay? That's only to get familiar with one language. I know you know programming, but different language have different proficiency. Just like you know Chinese, that means you know English, right? You know what I'm saying? So
yeah, I just haven't had time recently.
You still need to catch up, okay? I need you to finish it before we can go to the solo learn. I don't want to see you struggle in the solo learn, still don't know what is a function, okay? Okay, so please spend some time on it, okay? Next week, we will start the solo learn programming, okay? So it will be, if you are assigned to Monday, you go Monday. If you are assigned to Thursday, you go Thursday, okay? For student in Taiwan, knowing the notion, actually, you are a little bit slower, okay? We don't rush that fast. But if you finish, you can let me know, okay? You are solo learn. Also, at this moment, I don't know what time is good for the student in Taiwan so far, okay? Maybe Tuesday, maybe the end of Friday, continue from our original time because it's very harder for you to find another time, okay? So that's why I did not set up the sign-up sheet for you guys. But if you finish, you can start a solo learn. Is that okay?
Okay.
Okay, but since you are lower grade, in school grade, you are lower, you are younger, okay? So we do not actually rush you that fast, okay? Okay, no problem. Any questions so far?
No.
No, that's it for today, okay? We will see you, most of you. Sarah, you are okay to start the coding bit, okay? But I really wish you to finish the certificate as well. You see that Harrison is only 6th grade going to 7th grade, okay? So that's doable. I think you can finish it. Is that okay, Sarah?
Yeah.
Just rush it to the end, okay? That's not even a problem for you, I think. But need to get the proficiency in the language, okay? You know, the reason why we train you for 4 language before college, that's because when you go to Berkeley, there's no time to learn language. They'll jump to Python 4 right away, okay? There's no time to teach you Python 1. So you in high school, you really need to bring yourself up to a certain level, okay? Otherwise, you will be trading. You will be following people all the time, and you will feel frustrated, okay? That's why here we do use a very tough schedule, I would say, tougher than other teachers do, okay? But we'll bring you level from easy part to hard part, make you every one of you become a good programmer in school, okay, in college. But you need to cooperate with us, okay? That means that you need to go through a very tough schedule, much tougher than normal high school teacher is. That's why my EC Academy still exists, because I'm not teaching the stupid guy, okay? I'm not teaching the kind of student that got a D and then need to go to a cram school to make up their score. That's not the typical student that I teach. I usually teach the student who will go to Berkeley CS or go to CMU or go to MIT. Okay, that's the typical student that I teach. Okay, see you next time. Bye bye.
Thank you. Bye.
Bye bye.
Bye,
Bye bye.
thank you.
Bye.